Okay, I'll just start a record. So, hello, welcome everyone. Thanks for coming to attend our VQA2VLN tutorial, and I wish you enjoyed our talks today. And thanks for since reminding today is actually Father's Day. So, well, we indeed have a lot of fathers in this room, the father of VLN, the father of Touchdown, the fathers of lots of pre-training models. So, yeah, happy Father's Day. So this is our last session, and we will host a live panel discussion with all of our speakers and the organizers. So if you have any questions about today's tutorial's contents or just the general questions to the whole community, you can post your questions to the chat board in this room. I will repeat the questions and queuing our speakers to answer. So when you post your questions, please also let me know who do you want to ask. And of course, you can ask the whole panel. Please note that this discussion session will be recorded, and we encourage everyone to turn on your camera. So now I will ask the members of this panel to introduce themselves. First, I will start with me. My name is Chi Wu, and I'm an assistant professor from the University of Adelaide. My research background is mainly on machine learning, computer vision, and natural language processing. I'm leading the group of vision and language research in Australia Institute for Machine Learning. I'm especially interested in the problem of VQA and VLN. So thanks. So now let's start from Peter. Peter, can you introduce yourself?
Thanks, Shi. So yeah, I'm Peter Anderson. I'm a research scientist at Google. I've worked on VQA and VLN and sort of made, I guess, a bit of a journey from the first to the second. More recently, we're sort of focused on building large data sets for VLN and doing that with, methods for generating environments and synthesizing data sets. So there's a talk in the Embodied AI workshop that gives a good overview of the kind of current interest of me and some of my collaborators. Thanks.
Okay, thanks, Peter. So next, how about Yoav?
Hi, I'm Yoav Artzi. I'm a faculty at Cornell University. I work mostly on natural language processing with a lot of work happening in vision and robotics as well. I'm mostly interested in featured language understanding and grounded language understanding.
Thank you. So next, Zhou.
Hi everyone. So my name is Zhou, and I'm a researcher in Microsoft, and I'm also working on vision language representation learning, and maybe more recently, more focus on vision language pre-training. Yeah. So I think I have already know many of the people here, and that's so I did two internships in Microsoft back then, and yeah. So both my previous mentor was Xiaodong. And I think back then I also have a very small period of overlap with Peter and also Xin. So Peter was when we do the internship together in Microsoft, in MSR. And then we also went to CVPR 2017 together sometime. Yeah. So back then. And the Xin was, yeah, maybe I introduced too much, but yeah, so happy to see each other. Yeah.
Yeah, that's great. Yeah, it's good to know that everybody are good friends, right? So you talk about Xiaodong. So next, how about Xiaodong? Can you introduce yourself? Sorry, Xiaodong, can you hear me?
So maybe the LTE signal is not good.
I think he's talking. No, so yeah, so maybe next one will be Xiaodong. So how about Linjie? Linjie, can you introduce yourself before Xiaodong? So give some time to
Yes,
Xiaodong.
of course. So hi everyone, my name is Linjie and I'm a researcher from Microsoft. So previously I started my journey into vision and language with a VQA project, and then moved to like a vision language pre-training, and then on both image text and then video text. Yeah, thanks.
Thank you. So Xiaodong, are you ready? No, seems not. So how about Xin? Can you introduce yourself? Thank you.
Thanks, Qi. Hi, I'm Xin Wang. I'm from UC Santa Cruz, and I'm an assistant professor here. And yeah, my research interests mainly include natural language processing, computer vision, and machine learning, especially building embodied AI agents that can communicate with humans using natural language to perform real-world multimodal tasks. And most recently, I have also been working on multimodal fairness. Thank you.
Great, thank you, Xin. So next one, Luowei.
Yeah, thank you, Qi. Hi, everyone. My name is Luowei. I'm also from Microsoft, just like Zhou and Linjie. So my current work focuses on video and language pre-training, as you probably have seen from my tutorial video. And overall, I'm interested in video plus language and also other video understanding tasks in general, like action recognition. Yeah, so like Zhou mentioned, like I also know many of you and also heard of many great work from many of you. So I'm really happy to see you all and really happy to join the discussion.
Thanks, Luowei. Yes, yeah, I saw a lot of news about the clay bird, right? So it's quite good. Yeah, thank you. So Xiaodong, are you ready?
Yeah, I'm.
Thanks, can I hear?
Okay, yeah, sounds good.
Can I hear me? Okay.
Yeah.
Can you hear me? No?
Yeah, that's right.
Great. Somehow it's match preference. Okay. So this is Xiaodong. I know many of you are on the panel as well. So I'm now working for JD.com in China. So if for people who don't know JD.com, so revenue-wise, we are the largest company e-commerce in China. So at JD.com, I'm leading the JD AI research lab and working on natural language, computer vision, speech, machine learning, knowledge, understanding, and things like that. And we also spend a lot of effort to put this research into product, into a real-world scenario, and also get feedback from our customers to lead to the next stage. So before joining JD.com, I also worked for Microsoft Research and Development. So that's there, I work with many of friends, including Zhou, just mentioned, and Peter, I guess, and many others at Microsoft on the topic of vision language, I think from caption to VQA and many other applications. So nice to meet you all.
Okay, thank you, Xiaodong. Okay, so considering we don't have a lot of audience here, maybe we also ask our audience to introduce themselves. Is that okay? So how about Ashwaya? So do you want to introduce yourself? Great.
Hi, sure. I'm a PhD student. Just finished my second year at NYU. I work with Kyungyun Cho and Yannicka, and I am interning at Google this year, working on some vision language training plus applying it to like vision language navigation after.
That's great. Yeah, please ask some questions later.
Okay.
Okay, so how about Yichong? Do you want to introduce yourself? Hello, Yichong. Well, I guess the answer is no. So how about Zhen Yuan and Yan Chao? Do you want to introduce yourself? You don't need to turn on the camera if you don't want to, but yeah, if you can introduce yourself, that would be great.
Hi, yeah, sure. Yeah, thank you. Yeah, my name is Zhou Yuan, and I just recently graduated from University of Rochester, and my advisor is Professor Zhou. And recently, I have also been working on vision language related topics, and I will actually also will join Microsoft soon to continue working on related topics. So yeah, thank you for the great tutorial, and looking forward to the discussion.
Okay, thank you very much. Okay, so we don't have a lot of people in this room, so but I think this will still be a very active discussion. We have a lot of good speakers. We have a lot of good researchers. I think we still can discuss a lot of good questions. So if you have any question about it, well, even you're a speaker in this room, you have questions, you can post it on in the chat room, and I will repeat those questions. So well. during your typing, so actually I have prepared some questions so we can start to discuss. So I will post my first question. So I will just put it in the chat room so everyone can see it. So basically, my first question actually is my personal question, right? So the pre-training is actually a dominant paradigm in the current vision language, right? It's getting harder and harder for university researchers like me. So my group, we only have limited GPUs, right? It's very hard for us to follow this area because we don't have enough GPUs as the big companies like Microsoft or Google. So the saying is that we cannot pre-train a good model, then we cannot beat SOTA. Then it's getting harder and harder for us to publish a paper. But if we use some pre-trained models in our paper, then reviewers may say, well, it's not your model, it's not your pre-trained model, right? It's not novel, and the improvements may just meant from the pre-training. So, well, my question is, what can we do? So, Peter and Zhou, so you are all in the big companies, right? So, what's the feeling, sitting on a lot of GPUs?
I think this is a legitimate problem, or certainly a very good question. On the other hand, I mean, reviewers can be deadly, right? Reviewers may say, well, this is just training with lots of GPUs, and it's predictable that it does better, and that may also be hard to publish, like the sort of GPU-driven work as well. So I'm not sure that it's sort of any easier on either side, but I think there's lots of directions that do not necessarily just need more GPUs, and people are not looking in VLN, for example, as closely at the data augmentation in terms of the instruction generation stuff. So there's been probably only 2 papers really that have investigated that, and even for those, it wasn't necessarily the dominant part of the paper, and then not much follow-up work. So I think there's lots of areas. That's just one where there's opportunity to make progress without deferring GPUs.
Yeah, I think it's true for the VLN because VLN is not that a big area like whole vision language, right? It's just a small direction in the vision language. So I think the reason that we haven't seen a lot of papers about pre-training on VLN is just because currently it's not that hot. So but for the whole vision language, like video language, I think Zhou, Luowei, and Linjie did a lot of work on the video language pre-training. So how do you think? You are from companies, of course you can use those kind of big GPUs and data. But what's your opinion of this kind of trend?
So maybe I can first provide 2 data points. So 1 data point, and then I think both Luowei and Linjie and other people can provide further thoughts. So it's just some thought I currently have. So I feel this is not a problem just for vision language. So if you really think about it, it's about the current trend of doing very large scale pre-training, and so honestly speaking, so the vision language actually just kind of not very big community, right? So if you think about the people who are doing language model pre-training, or the people who are doing self-supervised pre-training for visual representation learning, they also require a lot of resources. So for example, the current popular, no matter is vision transformer or MLP mixer, or so they all require resources. So if you think about T5 or Robota or this kind of language model, so it's kind of so on one hand, I think so this kind of model, so this kind of paper, they are necessary, right? So at least there are some people or some researcher, no matter in academia or in the research lab, they can show when the people scale up and what the performance can be. But on the other hand, I also really believe this is, we cannot just focus on this. So otherwise it's kind of, so maybe we also need people to think deeper. So I don't know. So So for example, on one hand, if you are in company or in the industry, in the industry lab, I feel it is easy for you to judge, to justify you want computing resources because you want to chase SOTA, you want to be the top performance on one leaderboard. But then, so I feel in the company it's not easy to justify, I want to study the robustness of VQA, for example. So it's kind of not easy. I feel it's not easy to motivate. But on the other hand, I also think these kind of topics, they're also very important. And
that's
yes.
right. Yeah, I agree with you that of course pre-training is very important, especially it gives us a new SOTA and the model is very useful. The BERT, the clip. Well, we're not talking about the model architecture itself. The model, the parameters itself is very useful. So I think maybe for the researchers in the university, we need to focus on how to develop more much better downstream model, downstream frameworks to how to benefit from those pre-training models, right? Yeah.
So it's also been somewhat difficult for people to publish the large pre-training models. I think Zhou and Linjie probably can testify. I think Unitel took at least one submission until they got accepted that I know of. I don't know if Roberta in NLP was ever actually accepted to a conference. People are kind of like, oh, this is just a big model. It's just more data. And despite the impact, so it can go both ways to some degree.
That's right. Yeah, I agree. So yeah, so you're also from university, right? So for you, so I'm not sure how many GPUs can you use in your university. So for us, for me, it's just like well, just around 10 for my group. So it's very small scale. So we cannot use well, sometimes we even cannot fine tune the BERT model. So how about you? So do you have same concerns like well, how should we do our research with all those GPUs, and it's getting harder and harder to follow those pre-training models?
Yeah, I mean, I don't have a lot of GPUs. I'm embarrassed to give the exact number. But just an anecdote. One of my students just graduated and he's starting a position in NVIDIA, and he's like, it's like talking to him as if you have seen the light, the amount of computation available to him. And I'm sure Google and Microsoft are probably even bigger. But I'm not particularly worried because I am mostly just interested in other problems and in other modes of learning. So I think pre-training is a good initialization, and I'm actually very appreciative of how industry labs are pushing these models out. In NLP, even when they're slow to push it out, Hugging Face is kind of like catching up and pushing it out before them, which I think we all find very useful. But it kind of like, it's actually, there's this interesting benefit from that, because these parameters, they put us in a position that it would otherwise be very difficult to be in, to learn, in my case, in a lot of interactive environments and for interaction, where the amount of data that you can reasonably expect to in new environments or stuff like that is very limited. So in that sense, it's like it's a whole new avenue, and I think we see this in recent years with a lot of few short learning and adaptation from sim to real and stuff like that. That are maybe I'm not sure we could have thought about doing them at the way we're doing now without these models kind of like initializing our models.
That's great. That's a good point. So anyone else want to share ideas?
Yeah, I want to add a few comments actually to both Zhou and Yoav's comment. So at least my observation is that the very first model in like video language or image text pre-training, they're all from university labs. So I guess if you want the ultimate novelty, you don't need to be in a company research lab to have all the computational resources. And then even after that, after we observe like many image text pre-training models, at least what I know from like Mohit lab in UNC Chapel Hill, they are doing a lot of work to extending their the pioneering works in vision and language pre-training, and they're not using that many GPUs. If I remember correctly, they are using like RTX or something, and then it's only 4 GPU. Yeah, so I think there are many directions to explore. It's just maybe the industry and the university research that they're going to different directions. Yeah.
That's right. Yeah.
Yeah.
So,
actually, I agree on that. Yeah, actually, I agree on that because I also feel for some work you need a lot of GPU, but still beyond that, you still have a lot of new work you can explore. And somehow, from the application point of view, it's light, but still keep the performance kind of like performance. Small model will be more popular actually, and will be adopted in many other places easily. So that's actually will also have an impact. So another area is how we understand this big pre-training model. I think I saw some good work from universities try to understand like first in NLP. So those kind of work also help us gain deep understanding of this huge model. And that's what guide us move further rather than just train another big one. So I think this kind of work we really expect from academic society. I mean, from the university, give us some really deep thinking, some insight. What's the next step will be, not just incremental improvements on the already large models. So from that point of view, I really expect the university will come out more new good work. Yeah, that's it.
Yeah, thank you, Xiaodong. Yeah, so it's good to know that.
So,
I will let my students know that they don't need more GPUs to do the work.
I actually have a quite mixed feeling about this. So first, I really think pre-training is a very effective research direction to move from model-centric AI to data-centric AI, which I think data is really important and are getting much more and more attention from the research community. That's good. But meanwhile, because I work in the university, sometimes I would be worried about the computing resource, how we are going to compete with big research labs in the industry for many research topics. But I also think that's good for us, for academic research, because it forces us to to think differently. So like recently, because I just joined UC Santa Cruz, I don't have honestly I only have 1 GPU server right now. But most recently, I think I did some works purely on the analysis side. I even wrote a paper wrote a theoretical paper most recently without any GPU resources. But yeah, I think science and research is not all about methods and better results. So we should, I think we should definitely educate the new researchers to be more open-minded about the research field. And so sometimes even we are not developing a better method or a better result, but we can really diagnose the tasks and methods then which would be very helpful for future work.
Yeah, thanks. Yeah, I totally agree. I wish we can have more reviewers like you in CVPR or ICCV. So we recently submitted a paper about analysis of VLN models, but reviewers just say, well, there's not new models, no new results, so reject. So we wish we can have more reviewers like you. That's good to know. So
actually, one last comment. Yeah, I mean, so that's interesting. I mean, if someone say pre-training isn't new, is ungrounded, right? So because people have been using pre-training for the last decade, so you can say like faster RCN, they are not new because they are using ImageNet pre-trained model. So the argument, I feel you should probably tell that to the reviewer, but I would not recommend you like, but I mean just some like my thoughts. But Another, just following up the discussion from earlier, so I totally agree with what Zhou and Xin and also other people mentioned. So this computation dilemma actually encourage people to push boundaries from different routes. So like in the industrial level, so people are focusing more research that can better align with the product. So if you think about like a VIT, CLIP, those kind of work, so people are trying to remove the inductive bias such that they can scale better for large model, large data. And that's a really valid, really great direction with a great potential. And on the other hand, like in the academic level, so people are also looking to like how to efficiency leverage the data we have, say in the vision community. So how to use ImageNet 1K and or like something even smaller to better leverage those limited data for like to just extend that capability. So for example, the date and also recent paper from MSRA, like the BATE paper. So they're also looking at how to efficiently use the limited data we have. So I totally agree. Like, so the this kind of dilemma actually stimulates like people to push boundaries from different angles, which I think this diversity is definitely something that can enhance the whole community. Yeah.
That's right. Yeah, it sounds like we are only can solve those corner cases, and big companies will solve the big problem. Yeah, but yeah. Okay. Anyway, so any thanks for all of our speakers. Any audience want to share their ideas about this question? Okay, so if it's no, so if the answer is no, so let's continue our discussion. So, well, thanks, Ashwarya. She asked the question about the VLN. So I guess Peter will answer this question. So her question is, how important are object-centric representation for VLN vs instance-level image representation like those obtained use large-scale dual encoder pre-training using clip style approaches? Do you think phrase grounding, maybe using the deter, so like a detection model, would be helpful pre-training task to identify key points in the image? So I think the first question is about the VLN. So it's like whether we can use the object representation, right? So how about Peter? So do you want to answer this question?
Look, I mean, this doesn't have to go to me, but I'll make one comment and then pass it on. We made some decisions when we set up the room-to-room data set for VLN, which were fairly ad hoc at the time. For example, image representation, we took from a panoramic image, which we discretized into 36 views, and then used CNN features from these views, and we helpfully published those CNN features that were pre-extracted. And many works have just kind of continued to use that same vision setup without giving it a lot of thought. So I would encourage people to kind of throw that away and do something better. Absolutely. And I'll turn it over to the other speakers for maybe what the something better would be.
Yeah, so I think her question is about whether we can use, object-centric representation. It's like just like your bottom-up attention in the image captioning. So previously, people just know, okay, we can use the whole image features, or we can use the dense grid region features. But then you'll find if we use the region-based features, like first detect those interested objects, then use those object representation. It's called object-centric representation to improve the image captioning performance. I think Ashwarya's question is about, well, whether we can use object-centric representation to improve the VLN performance. So yeah, so Yicheng is here. I saw Yicheng actually recently published a paper in this year's CVPR, which is about VLN, but I think he used the object-centric representation. So Yicheng, do you want to introduce your work here, or do you want to share some ideas?
Oops, sorry. Wait a second. Can you hear me?
Yeah.
Yeah, so in that work, we didn't use object features. And yeah, but from our previous early experiments, we think objects are too sparse in the VLN datasets. So I think the dataset itself is not good for learning the object-text relationship. But on the other hand, objects are indeed very important landmarks in these navigation tasks. So yeah, I think it's still very valuable to think about how to introduce objects like via pre-training vision language models or other methods into VLN.
So
yeah.
I can actually, I personally think that objects are super important. My intuitive but non-expert view, because it's coming from Coxsci, is that humans have biases towards objects that are observed in core systems. So it's kind of like shows that if you reason directly about objects explicitly, you can reason efficiently, assuming the human system is efficient. Of course, cognitive science is very much in its infancy, so it's very hard to draw very broad conclusions from that, and our models are completely different. We did something a bit that kind of like that used object-centric explicit alignment between phrases in text and objects in environment, not in room to room. We did it in our drone case, and what we found is that if you can get this alignment to work, which there is a big if there, you can actually use it for to very quickly expand your system using a few short learning or a few exemplars, because you have these direct alignments. So then you could think about taking, so first of all, you could possibly, doing this way, if you can train the alignments well, you could think about doing reasoning in room to room or room across room, or in the scenarios that we did, that can reason about objects that are at the low frequency end of the tail. So that there is just no chance that you could learn about from like the very few instances that you see in the data. Now, the critical question, of course, there's this like big if, how do we actually get this alignment? And so we had this solution with like kind of like synthetically generating tons of data in augmented reality, but if I was to start doing this today, I mean, this project started about, I don't know, 2 years ago. If we started to do it today, I would probably try to go back to our first question and look at what we can get from pre-trained models, maybe to kickstart this process.
That's right, thanks, Yoav. So as well, also ask like, well, maybe it's because the pre-trained object detector were not finding the relevant objects. I think, actually, I think, for example, in the Metaverse 3D, I think the recognition is not a hard problem, especially, those objects are just a daily object, like bed, chairs, those kind of things. I think if we use a good detector, we can definitely detect those objects. And, one experiment we can do is, well, in the Metaverse 3D, they also release the ground truth object features. So maybe, well, someone can try, if we use the ground truth object features, whether we can improve the VLN performance, right? So continue Ashra's question. Do you think phrase grounding maybe in teacher would be a helpful pre-training task to identify key points in the image? I assume this question is about pre-training. So how about Linjie, Luowei, and Zhou want to answer this question?
Yeah, maybe I can first provide one data point that that I want to say regarding to the previous question, and then I think Linjie and Luowei can add more stuff. So what I want to say is so I think a great feature that so they can be very strong, at least from our internal communication or with other people. So BOTD feature, they are very strong, right? Almost every paper use it, no matter it's VLN or general VL task. And then the current WinVL feature from Microsoft is even stronger, right? It's a stronger, so basically it's a stronger object detector. So the VQA performance can be boosted a lot. But the kind of great feature, so for example, from clip or from other. So for example, in this line of work, so first we have Pixelbird, and then in this year's CVPR we have Zhou, so it's from MSRA, and we also know actually the clip, the feature from clip, they are very
I think we lost the Zhou. Okay, so maybe Luowei and
I can provide another data point before Zhou come back. So yeah, I think he's back.
Yeah.
Kind of, but anyway, so I can start to provide a data point. So regarding the object-centric feature, so I saw a recent work coming from Google Research. So the title is Zero-Shot Detection via Vision and Language Knowledge Distillation. So they basically take a clip and leverage the zero-shot capacity of clip. You know, you can do like a zero-shot detection in a retrieval fashion, right? So you can always encode a new word through text. So that's exactly what they did. So they use a retrieval-based framework to do a zero-shot detection. So I think that's something on top of what other people said, like about like using pre-trained object detector. So I mean, like in the long tail scenario or in the zero-shot scenario, I think using clip inspired models like zero-shot based models could be some one direction to explore.
Just to add to that, I read the paper that you're talking about, and we also have a similar approach, or like not retrieval based, but basically that's why I asked about phrase grounding, because as I see it, finding the relevant parts of the image or like the panorama that is spoken about in the instruction is like essentially a phrase grounding task, because if you don't know what you need to find, how are you going to figure out if you need to, like, which direction you need to go around it or whatever. So that's why I asked if like phrase grounding from like how we suggested it in MDeter would be a good pre-training task, because I feel like that's a good application.
Yeah. So I can provide another data point. So actually it just came off the press, like from our activity in the entities challenge yesterday. So we noticed from the challenge, the top one, the winner solution, they so the task is video captioning and grounding. So basically we need to do captioning and ground the phrase in the video at the same time. So in order to evaluate how faithful the description is to the video. And it turned out the winner solution use a MDeter based method. So they use a 1.3 million image ground with also with the grounding box pre-trained MDeter to, and then further fine tune on our activity net entities data set. And so one interesting observation from the challenge is even without any fine tuning. So even though the model has not seen any video data at all, so it already outperformed really strong baselines from last year or from CVPR 19. So I mean that's sort of really high bar for grounding. So it demonstrates a great remarkable like generalization ability of image pre-trained model. So I think it has a great potential, and I agree. Like, so I'm not an expert in VLN, but in terms like as far as the grounding concern, I think MDeter or this grounding-based pre-training direction is a really has a good potential. Like that's something we see from the challenge. Like the winner outperform the second place by like 70% relatively. So which is a really mind-blowing results. So that's something we even have a discussion on Twitter, like Yang Lecon, which is also one of the paper of MDeter. He also shared some thoughts about this field. So,
hey, thank you.
Yeah, thank you.
Yeah. So any other?
Yeah, so, sorry, Zhou was saying something earlier, I think.
Yeah.
So you got disconnected.
Back.
Yeah, no worry. I don't have. So yeah, so my internet has some problem. Yeah, so I don't have much to add. I was just trying to say clip kind of feature, grid feature. They can be as strong as the WinVL feature. Yeah. And by the way, I just found Ashwaya is the first author of M data paper, right?
That's right. Yeah.
Wow, that's an impressive work. Yeah,
Yeah, it's really
Thank you.
amazing. Yeah. Nice.
Yeah. So Xin is come back. So whether Xin want to share some ideas about the object-centric features for VLN. So you are unmute. Yeah.
All right, sorry that I just left for emergency situation, so I didn't follow the whole question. But regarding the object-centric representations, I think right now the simulation environment are quite simple in the sense that there are only static objects, and especially for indoor environments, that you can imagine there are always chairs, tables, wall, doors, and yeah, the normal things you can expect in the house. But so I feel like if we can reconstruct a more dynamic environment which allows some moving object and even add some random noise into the simulation environment, then I think the object-centric representation and the reasoning ability should be more important to solve those tasks. And I do feel like outdoors simulation environment may require this kind of ability even more, like Yoav's touchdown data set and some other similar data sets.
That's right. Okay. Any other people want to share ideas about this question? No. Okay. So yeah, I have another question actually. So to people who are from companies like Peter from Google, Zhou from MSR, and Xiaodong from Jingdong especially. So how do you use this VL or VLN models in your in your industry? Is there a gap between the current research trend in the VL and VLN and the real applications? So how about Xiaodong? I noticed that you use a lot of VL models in your in Jingdong's online service or website. So do you want to introduce that?
Yeah, sure. Happy to share some thoughts on how to use this model on the real world scenario. So I will talk about the VL. VLN, I didn't see a big usage of VLN in a real application yet. I believe there will be a good potential to apply VLN for robotics, things like that. But I think it just takes some time. But for VL, I think there are a lot of applications. One application is, for example, we write advertisements automatically for many new goods, new products listed online on JD.com. So used to be we ask people to write those advertisement or introduction. Then now we actually use AI to write the introduction, and they actually basically our AI will even receive commission by if people click the ads or click the products with our comments on that. So in this application, we write the text with the input from the picture of the product, from the knowledge base of the product, and some other summary of the product as well. So it's not just a simple use of like a caption, it's more like multimodal input to the text output. So in that sense, we still need to ground the content in the image and the concept in a knowledge base, like a spec of the product, things like that together to output a faithful and fluent and attractive description of the product. So that's one of the application. Another one is more like dialogue. So in a dialogue, people, for example, contact the customer service. We have AI-enabled customer service agent to reply the customer. And sometimes the customer just take a screenshot and say, we have some problem like this. I mean, this refer to the picture. So we need to do some understanding of the picture together with the question that people post. And then find the right answer or ask the right questions, or have the continuous interaction with the customer. So that's another place we use visual language technologies. So we use all the features I think people mentioned, like the BOTD and others as well, and the pre-training model as well. That's a new direction. I think that's getting usage in the product, but I haven't seen a lot of research yet. It could be an interesting next research question. Is people now use a virtual human or digital figure to interact with the customer in a smart customer service scenario. So it's not just the customer call the phone or use text message to contact with customer service department. Rather than the customer service department will create a figure, create a a digital customer representative with all this image, with all this emotion on the face or things like that to interact with the customer. Let's provide a upgrade experience. But that means you have to synchronize the expression in your face, the expression of your voice, with TTI.
Oh. Hello, Xiaodong. Yeah. So let's waiting for Xiaodong. So Peter, so how about your side? So you are working on VLN in Google. So it's just a pure research, or do you use any VLN for the Google's products? Well, I guess it's secret, but you can share something with us.
I think VLN is not ready for products yet. I think three things need to happen first. One is just performance needs to, still keep improving. Secondly, we need to solve the sim to real transfer onto actual robotic hardware of some sort, or mobile camera or whatever it is. And thirdly, I think we actually need to look at dynamic environments, and particularly environments where people are moving around and have it work in that situation as well. And they're probably the three hurdles to kind of having this product ready. One other comment is that the inverse task of generating the navigation instructions is also something that has application. In many parts of the world, using a map like Google Maps is not an intuitive thing to do. And, we may have grown up with that, not everybody has. And so alternatives where you can give people directions in a sort of a conversational way, maybe with some images of landmarks that they need to look for along the way, like that type of thing could be very important in many geographies. So I would say the inverse problem, in some ways may even be closer to product.
Yeah, that's right. Yeah. So actually, this reminds me another question about VLN. So some people just ask me like, current VLN design, is like we want to replace human to finish the navigation task, right? So this is typical the machine centric. So how about the other way around? So like, say, how about if we use a robot to guide human to finish the navigation? So for example, it's not normal for a robot to be in a new environment. Normally, it's like a robot is in a familiar environment, always here, stay at home. But people come to the new environment, like for example, I go to a new building, I go to a new museum, and I have some questions about, for example, I want to see some. If I go to a new museum, I want to see a picture from Van Gogh. So how about we ask some question to the robot, and the robot knows all the information, and the robot gave us the guidance to how to navigate by ourselves. So we don't need the robot to navigate by themselves. So we want to find our place by ourselves, just like when we drive a car, the Google Map can give us some instructions how to approach my target location. So how do you think for the VLN, can we do the similar things for this one?
Yeah, I agree that sort of smart building application is potentially interesting too and practical. I'll let someone else carry on there.
Yeah, I have actually seen a few products regarding this direction. So I have visited a square in Shanghai and another shopping mall in the US. I actually forgot the city, but anyway. So there, but it's a non-movable robot there. So you can touch its screen and communicate with him. And then I'll ask which direction I should go to reach which store. Then it will show you the exact route to the store in the shopping mall. Which is kind of very fun. Yeah, and I do believe this is definitely a promising research direction for everyday use, especially for indoor navigation. And regarding this topic, I think another thing we can consider is how to help those disabled people, like the blind people. So if they can be equipped with an autonomous system or dialogue system that can communicate with them about the visual environment, and some, or even provide some navigation instructions for the blind people, then it would be a great feature and product for the blind people to improve their everyday life.
That's right. Thanks, Xing. So how about Zhou and Luowei from Microsoft? So do you have any? I noticed that on the PowerPoint, if you insert one image, you can have actually automatic image captioning. Well, although most of the times it's not relevant to the image. So, how do you use the VR models in the real applications?
Yeah, maybe I can try to first answer. So yeah, so I think you have provided a good example when you open your PowerPoint. So good to know you noticed this. Yeah. So the caption generated is by our team. Yeah. So
okay.
So basically it's so I can also tell you that image captioning system is really from VLP model. So it's not a simple model. It's a pre-trained model. So it's a large scale pre-trained model, but you need to do model compression in order that can be used so in real time. Yeah, but so I think in Microsoft there are many different teams doing vision language. So what I can say is first MSIA, they have a team doing vision language, and the Microsoft Research Redmond, they also have team doing vision so doing vision research, and our team, the other cognitive services. We also have image captioning API, and we are also doing the vision language pre-training. And by the way, BIN, they also have a multimodal team to do vision language. So from application-wise, from Microsoft, I think it's one is so image captioning. One way is to use the in PowerPoint, and another is like Xin said, is for accessibility. So that the visually impaired people can use it. They can have potential application. And then another is for image text retrieval. I think so this is used in BIN. But so that kind of application is more easier to be seen in other companies. So for example, so I know in Amazon they are also trying to build a unified model that can encode multimodalities, so that it can be used by the whole Amazon company for search. And I think in Microsoft it's the same. We're also trying to build a unified model. The model that can deal with the vision signal, and the model that can take the multimodalities into one feature vector for downstream task. Yeah.
Okay, thank you.
Yeah, maybe Luowei, Linjie can add some.
So I can talk about some applications from the video side and also multimodal. So there's a tool on Azure AI called a Video Analyzer for Medium. So basically, it takes a multimodal input, video, sometimes audio, and then do things like sentiment analysis, emotion detection based on the multimodal input. And also there are a couple like some other features like keyword extraction, like multimodal keyword extraction, name entities detection. So pretty much more NLP centered, I would say. So for those multimodal applications, for now they are quite NLP centered. There's another feature I think is similar to the YouTube video summarization. So if you have experience watching YouTube videos, and sometimes like people will provide like the key points, like the key segments, and also the topic of each segment. But if it's not provided, the algorithm can generate, like do the segmentation and also the topic summarization, maybe offline or on the fly. So that's something also we are actively working on at Microsoft. There's some ongoing efforts on multimodal and video summarization, this kind of stuff.
Yeah, I can also add another application for the video and language side. So we are looking into video, it's called audio description actually. So it's for visually impaired people, but because they cannot see the video scene, so there are professionals to add audio descriptions about the video scene to aid them in understanding the movie. So while this is a very hard task, as you can imagine, that not only you cannot repeat that repetitive information, and also you need to identify like the scene transition. So there involve many like not video understanding tasks, but also like the description generation task. So this is something we are also looking into as well. Yeah.
Yeah, great. So how about Yoav? So you're working on the outdoor VLN. So do you think is that applicable to some real applications in the industry? Is there any companies come to find you like I will give you 1 million to make it a product?
Well, I hope they'll give me more than 1 million.
Yeah.
I'm not sure. I think that the whole area is very kind of like nascent, both as far as perception, language understanding, and also as far as like, you know, if we talk about physical agents and robotics, robots are pretty far from being able to be deployed for use of non-expert users. So I like to have in my work the long-term application as the motivation. I think it's very important, but there are also many other aspects of the problem about language and perception and what VLN allows us to study as far as verbs and the different types of spatial relations that you see, how they show up in language, how movement shows up in vision. That these are all very fundamental problems. And for me at least, and you know, maybe that's the privilege of working in academia, these are the main drivers. And I'm more comfortable with like the applications coming down the road in probably longer time than maybe people in industry are more comfortable with.
That's right. Great. So anyone else want to share their ideas about this one? No. So okay, so I guess we are approaching the time. So it's yeah, it has been 1 hour. So I think if there are no more questions, I think this will be the end of this discussion session. So, thank you everyone. Thank you our speakers. Thanks our audience come to ask the questions. So yeah, this whole session has been recorded and I will put it online. Thank you very much. Thank you.
Thank you. Thank you, and everyone.
Thank you.
Thank you, everyone. Bye-bye.
Bye.